So let's move now to the solution Stoich. Keep in mind that this is the third part of the lesson 2, and it is a bit long, but it's everything that you need to know pretty much in terms of Stoich calculations. In solution, Stoich, what we will need to use is the molar concentration. Molar concentration. So molar concentration, let's review that. It is how moles do you have in 1 liter. So when you have volumes and moles, what do you use in order to move from volume to moles or from moles to volume is a molar concentration. So now what volume of 14.8 moles per liter ammonia is needed for the ammonia to completely react with 1.5 liters of 12.9 moles per liter of phosphoric acid. As everything that we have done, always will start with a balanced chemical reaction. So ammonium is reacting with phosphoric acid, and this is ammonium hydrogen phosphate, so NH42PO4, HPO4. Okay, so we'll start what is given here. First of all, what is given here is that the volume, so liters is question mark, of ammonia of 14.8 moles per liter to react with phosphoric acid. I will write it in a different color so you can see. 1.50 liters of phosphoric acid at 12.9 moles per liter. So we'll start with what is given, and what is given here is like fully given is this, as the phosphoric acid. Okay, so yeah, okay, so it is we'll write it as 1.50 liters of phosphoric acid. Molar concentration is 12.9 moles per liter, meaning that in 1 liter you have 12.9 moles of sulfuric acid. So 1 liter is 12.9 moles of sulfuric acid. So liters and liters is cancelled. What do you have up to this point is moles of sulfuric acid. Now, in order to move to what you are looking for, you have to use the molar ratio. So molar ratio is 1 to 2 or 2 to 1. So 2 moles of ammonia are needed to react with 1 mole of sulfuric acid to produce ammonium hydrogen phosphate. So 1 mole of sulfuric acid is using 2 moles of ammonia. So moles of sulfuric acid is cancelled out, and what you have up to here is moles of ammonia. And ammonia is with a concentration of 14.8 moles per liter, which means that 14.8 moles per 1 liter, or in 1 liter you have to add 14.8 moles of ammonia, and they are all ammonia. H3 and H3. So the ratio, now again, we have two ratios, ratio 1 and ratio 2. The ratio that we will use in order to figure out how many liters is ratio 2. So it will be 1 liter of ammonium is 14.8 moles of ammonia. So moles of ammonia is cancelled out and you are ending up with liters of ammonia, which is what you need. So now in terms of the calculator numbers that you will enter is 1.50 times 12.9 times 2 times 1, which we don't write, and then 1 and 14.8, and the units are liters of ammonia. And when you enter those calculations, you will find that you will need 2.61 liters of ammonium in order to react with in those conditions that are presented here. Okay. Next one is 10 milliliters of sulfuric acid will react completely with 15.9 milliliters of 0.150 moles per liter of potassium hydroxide solution. Calculate the concentration of sulfuric acid. So, like everything, we will start with a balanced reaction. So, sulfuric acid is reacting with potassium hydroxide to produce H2SO4 and water. What is given here is 15.9 milliliters and 0.150 moles per liter. And we are looking for concentration, 10 milliliters. Okay, we'll erase this and then. So again, we'll start with what is given. So what is given here is 15.9 milliliters. So 15.9 milliliters of potassium hydroxide. Let's convert it into liters. Why do we need to convert it into liters? Because the units are liters, moles per liter. So 1 liter of potassium hydroxide is 1,000 milliliters of potassium hydroxide. So milliliters and milliliters are cancelled out. Now using the concentration, so we have 0.150 moles per liter, meaning that in 1 liter we have 0.50 moles, or if we have 0.50 moles, then we will add 1 liter. So 1 liter of potassium hydroxide, 0.150 moles of potassium hydroxide. So liters and liters are cancelled out. What do we have up to here is moles of potassium hydroxide. As soon as we see moles, then we always move to the asking or the unknown. We will use the molar ratio. So now let's use the molar ratio. So we have 2 moles of potassium hydroxide is reacting with 1 mole of sulfuric acid. So 2 moles of potassium hydroxide is 1 mole of sulfuric acid. So moles of potassium hydroxide are cancelled out. And what do we have here is moles of sulfuric acid. So this sulfuric acid is in 10 milliliters or in 0.010 liters. Okay, so in order to find the concentration, which is moles per liter, so we'll have 10 milliliters for one, and then if we want to just do Stoich all the way through, then we can say that is 1 liter has 1,000 milliliters. So milliliters and milliliters are cancelled out. And then what we have up to here is the concentration, is moles per liter of potassium, sulfuric acid. And they are all sulfuric acid. So sulfuric acid, sulfuric acid, sulfuric acid. So in terms of numbers, what do I have is 15.9 times 1 times 0.150 times 1 times 1 times 1,000 over 1,000 times 1 times 2 times 10, and the units are moles per liter, moles of sulfuric acid. Okay, concentration of sulfuric acid. So when you enter this into your calculator, you should have 0.119 moles per liters of sulfuric acid. So this is easier than gases, but still you need to work on things. Yeah. Now we have 15 milliliters of sodium chloride reacts with 35 milliliters of 0.250 molarity lead to nitrate. Determine the molar concentration of sodium chloride. We'll start again with the balanced chemical reaction. So 2NaCl plus NO3, 2. Okay, so 2 here. And then what we have is 15 milliliters. And we are looking for concentration. And here we have 35 milliliters. And the concentration is 0.25 moles per liter or molarity. Okay. Now we'll start with what is given. So I'll erase that and then. So we'll start with what is given. 35 milliliters of PbNO3, 2 times 1,000 milliliters, 1 liter of PbNO3, 2. So milliliters and milliliters is cancelled out. Now we have the concentration. So in 1 liter of PbNO3, 2, 0.25 moles of PbNO3, 2. And as soon as we said, as soon as we have the moles of the known, then we move to the unknown, moles of the unknown using the molar ratio. So 1 mole of PbNO3, 2 is 2 moles NaCl. So moles and moles are cancelled out. and this is in 15 milliliters, and 15 milliliters are or one in one liter we have 1,000 milliliters. So now in terms of numbers, we have 35 times 1 times 0.25 times 2 times 1,000 divided the whole thing by 1,000 times 1 times 1 times 15, and you should have 1.17 molarity of sodium chloride. This concludes the solution. We'll continue now with percent yield. Is a bit short, and then this is the lesson 3. So percent yield is the ratio of the actual product obtained compared to the calculated product. The calculated product, which is theoretical, based on the calculation. So the experimental, what it is coming as a result of the calculations. So now, experimental yield are the result of the experiment. When we are doing an experiment and we are measuring what is the precipitate or the volume of the gas, and so then this is the value that is counted for the experimental yield. And the calculated yield is what is obtained from the calculations, from the Stoich calculation, okay? From Stoich calculations. So percent yield is the experimental value or experimental yield over the calculated one times 100 converted into percentage. Now this never exceeds 100%. In the ideal situation is 100%, but always is less. No, is less than 100%, because every experiment take into the consideration some errors. So let's see now what is this example here. In chemical analysis, 2.50 grams of sodium react with magnesium nitrate. What is the precipitated mass of the precipitate? Okay, so now the chemical reaction that we are dealing with here is sodium is reacting with magnesium nitrate to produce sodium nitrate plus magnesium. So when we see this, the state of matter is solid is for sodium, aqueous is for magnesium nitrate, and aqueous is for sodium nitrate, and for magnesium is solid. So the precipitate is this one here, magnesium. Okay, so now we have 2.50 grams of sodium reacts with magnesium nitrate, and we want to know what is the grams of magnesium. Okay, now this is the case of gravimetric Stoich. So we will go what is given, 2.50 grams of sodium times, using the molar mass, we will find that in 1 mole of sodium, we have 22.99 grams of sodium. So grams of sodium is canceled out. Now we'll move to the unknown because we have moles of sodium of the known. So now we'll have 2 moles of sodium is 1 mole of magnesium. So moles of sodium is canceled out. In order to find the grams, we will use the molar mass of magnesium, which is 24.31. Okay. And 31. So 1 mole of magnesium is 24.31 grams of magnesium. So moles of magnesium is cancelled out, and we have 1.32 grams of magnesium. This is as a result of the calculations. So this is theoretical or calculated yield. Okay. Now, group A obtained 160 grams of precipitate. Find the percent yield. Okay, so now percent yield will be experimental value over calculated times 100. So we'll have in this case 160 grams over 132 times 100 equals 121%, greater than 100, which means that it's not right. Something is wrong on the calculations. And group B obtained 107 grams of precipitate. So percent yield is experimental value over theoretical value or calculated value times 100. So 1.07 over 1.32 times 100 will be 81.1%. So in this case, if we're asking which group has the best result, we'll say that is group B. Because you cannot have an experimental value that is greater than 100. Possible sources of error are several. So the one that is most common is that it's not dried properly. So there is water in the precipitate. If you may have some impurity in the reaction, or for both of them, A and B, the reaction not gone to completion, so it's not completed properly. Now, let's take a look now to the other example. In a chemical analysis, 3 grams of silver nitrate in a solution was reacting with excess sodium chromate to produce 2.81 grams of filtered dried precipitate. So again, we will calculate using Stoich. We will calculate the theoretical or calculated calculated yield, and then using the percent yield, we will calculate the percent yield formula. Now I will just give you the numbers here. So the calculated yield is 2.93 grams of and percent yield is 95.9. Pretty good experiment. You can try on your own. Example 3. And this will conclude the lesson.